Hello everyone. First of all, thank you so much for joining us. So in today's session, we'll be learning about Dockers. So what we'll do first, we'll try to understand what is Dockers. Later on, we will try to understand their benefits, and also we'll try to understand the architecture of the or Dockers basically. Later on, we'll try to see some commands. We'll try to understand how the Dockers components also works, right? So let's get started with the definitions. So as I told you, whenever like Dockers is something everybody is familiar, right? But they may not know the exact terms of why we use Docker. So this is a repository. This is made by myself. You can also access this repository here. When you talk about the first day one, that is your getting started with Docker, you will have a like a introductions where it is given the definition of the Docker. So Docker is an open source platform that simplifies the process of developing, shipping, and running application in containers. Containers are lightweight, portable, and isolated environment that packages an application along with dependencies, libraries, system tools, system libraries, settings, ensuring consistency across different environments. So what we need to understand here, we need to understand three things here. When I say Docker, first thing you can also think of the Docker is basically open source platform, right? It is an open source platform that simplifies the process of developing, shipping, and running application. This in the containers. These three terms we need to understand. First is your developing. First we will develop, then we will ship, then we will run. Now coming to the point for the first, that is developing. Question is, what is developing? Developing is nothing but, say for example, I'll take a small example of the code. Let's say we have a GitHub account where we have a repository. I will just take any random repository so that I can explain better. Say for example, we do have a .NET based applications, right? So as you can see within here, we do have an application code here. You can have, this is, say for example, this is a .NET based application now, right? So this .NET based application, we have a code basically, application code. Now this is a code basically. Now this application can be deployed any of the environment as long as you have the environment ready, right? Same way, even Docker also, I mean here when comes to the, let me make this here, right? When comes to this one, Docker also, like first we will develop. Develop is nothing but what exactly it is there. Whatever application code we are having here, let's say we have a, in my case it is .NET based. This one I have to develop as an application. That one I need to make as an application. I need to develop this one. Develop in the sense like I need to containerize this one. So this is all images, right? I mean application code we are having, we have to develop this one. Let's say in my case it is already developed everything, but then we need to containerize this one. So as I told you, we have so many components, we will understand that also, but for now understand that we need to develop the applications, and it is this thing. Next, once it is containerized, then what we will do, we will ship in the sense basically where exactly are you going to deploy this application, as simple, right? That means you will build the application. Where question is, where are you going to deploy that one? As simple, right? Deploy means you maybe you are going to deploy in your particular dev environment in the cloud service, or could be any particular this thing, right? So this is where it is. This is what it is. And then running application in a container. That means, as I mentioned, we have a container applications. I mean, we have a container based applications. This one you can deploy in your way container. Basically this application you can run basically in your containers. Okay, now what is containers again? Container is nothing but it's a lightweight, portable, and isolated environment. That means you can imagine, right? The container is a containers are lightweight, portable, isolated environment that packages an application along with the dependencies. That means whenever I say container, it simply means that it basically the lightweight, also portable. As the name suggests, right? When I say lightweight, it will very much lightweight, right? That means you don't need much space or much memory or any kind of CPU configuration or any high configuration not required. And also it is portable. That means you can move around anywhere, you can deploy wherever you want as long as you have the environment ready. Then also isolated environment. So isolated environment along with it also has the application slides dependency file. So basically, say for example, we have our application that is a .NET. Now, in order to run these applications, what we need first, we need to have the all this particular application related dependency file, it's we should have it ready, right? So whenever we have these applications components ready or maybe dependency ready, then only our application will be able to work properly, right? This is the reason why we using the containers that has your what do you call it, has a package like your dependency files, libraries, system tools and system libraries and settings, everything, all ensuring consistency across different environment. So now let's say in this particular, now we are deploying, let's say in dev environment, same packages, if you have this thing image ready, this can be deployed to a different environment. Okay, so if anybody asks what is Docker in simple way, you can say that Docker is an open source platform that simplifies the process of developing, shipping and running application in container. That's it, you can tell that one. Now what is container mean? You can mention containers are lightweight, portable and isolated environment that packages an application along with dependency files, sorry, dependencies, library, system tools, system library, settings and ensuring consistency across different environment. That's it, you should know for now. Okay, so we'll come to the another components now. Now let's go with the architecture, we'll understand. So we'll try to, this is important for us to understand architecture also. So as you can see here, I in your Chrome browser, I type Docker architecture diagram. So as I type here in your Chrome browser, you can, there are so many documents where you can also refer it, but I would prefer to use maybe official documents that explains well, but in details, right? So let's take a look that. So as I mentioned, I'm going to type this one. So if you come down, there is a option Docker. There is a, this is from the tutorial. I don't want that. I want to go with the official documentation. So maybe I can go with the official, if you share a Docker doc. This is from the official documents. I mean Docker's website. I mean, and now if you type here, first thing we'll understand the, as I mentioned, Docker. You can also use these terms. Docker is an open source. What is Docker means? Docker is an open source for open platform or open source platform, you can say, developing, saving and running applications. Docker enables you to separate your application from your infrastructure, so you can deliver software quickly. Okay, so you can take a look later whenever you get time. Next thing is that architecture part. Coming to the architecture, this is the basic architecture as part of the official documents. So first, what we need to understand here, you, if you want, you can go through this one. Let me read one through this. This basically the definition. Docker uses a client server architecture. The Docker client talks to the Docker daemon. Okay, remember this one. Now, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same machine or system, or you can connect to a Docker client to a remote Docker daemon. The Docker client and Docker daemon communicate using the REST API. So they communicate using what? REST API. Our Unix sockets or network interface. Another Docker client is Docker Compose that lets you work with application consisting of a set of containers. For now, we can ignore this per compose pass. If you have multiple set of containers, we can use a Docker Compose. Let's not discuss now. That means, so what we need to understand here, when it comes to the architecture of Docker, we need to understand three different components. The first is client. The second is Docker host. Third is a registry. These three things are very much important for us to understand. What we need to understand here, so whatever, whenever I say client, so as I mentioned, there is also a definition. You can go through each this thing. Let's say if I say Docker daemon, what is meant by Docker daemon, or I can call as a Docker D. Okay, so Docker daemon or Docker D listens for Docker API requests and manage Docker objects such as image, containers, and networks and volumes. Docker, daemon can also communicate with other daemons to manage Docker service. So it is maybe not that clear, but as I mentioned, you have to go through this one. So what I have done is this part, whatever, as I mentioned, three categories, right? I mean, basically, we need to answer three different. I have made a note so that it will be easy for you to understand it. So according to the official, I have made this simpler way. Let me check. It is. Can you see somewhere Docker here? Master. Let me just refresh. Let me check. I think here only, right? Okay. Yeah. Um, I will show you this one so that this is much easier for you to understand. I'll referring the basically the architecture. So as I told you, there are three main parts we have in Docker diagram basically. First thing is the client. Second thing is your. Let me make little zoom better. Yeah. Yeah. Okay. First thing is your client. Second thing is your Docker host, then registry. This is what we have just now we have checked now here as well. Here, right, this diagram, if you see the client, Docker host, and registry. So now what we have to understand here, client, when it comes to the client is nothing but where you type Docker commands. So wherever you type the Docker commands, basically that is your client. This is where a user interacts with Docker using the commands. Basically, whenever you want to interact with the Docker site, so basically you need to type the Docker commands, right? This is where you work with, that is in a client. Okay. Example, you want to run Docker run. What it does basically runs a container from an image. Same for if you want to build a Docker or if you want to build the image, basically Docker build, you can use a build a custom image from a Docker file. So basically, whatever commands you're writing in your Docker site, so this is basically doing in your clients only. This is where you type the commands. Similar to way, similar to way. Okay. Oh, okay. Um, Next is we'll understand the Docker host. Docker host where Docker actual works. That means the actual command where you are running, basically in the sense the where how the actually the Docker is working. It is working on your Docker host. This is the machine where Docker is running. So whatever you're running commands and anything, it is actually running in your basically what is Docker host. So we have it here, Docker daemon, the core engine that does all the heavy lifting, and also images ready to use packages, application, example Python Redis or Redis. And we have a containers, running containers instance of the image. Let's say if you want to run the Python based applications, right? So basically that means Docker host responsibility is to basically run the commands and also based on that whatever, let's say you want to deal you want to work with the images or you want to work with the containers, everything their responsibility is to take care of this part. Okay. Example you can see here, Docker run. Let's say I want to pull the images, right, from the Docker, sorry, from the Nginx. Then this is the responsibility, that is your Docker host. Then we have the last, that is your Docker registry. Sorry, or you can just call as a registry. Registry is nothing but it is a storage for Docker image. So as we all know, storage mean basically is to store your Docker image file, right? So once you containerize the image, you would be storing somewhere, maybe in public or private repository, depends on the project. So this is like a library or storehouse of Docker image. It stores popular base images like Nginx, Ubuntu, and PostgreSQL, etc., where you can run Docker pull, Docker downloads from there. And you can also push your custom image to a registry, example Docker Hub or JFrog. This is another third party actually, but this is a public one actually. That is a Docker Hub. Okay. Then in the simplest way, you can think for now, let's say client is nothing but where you type the commands, right? Docker daemon is nothing but engine that does the work. So everything, whatever it is going to do or perform something or the task, it will be done with the help of Docker daemon. Similar way, image we all know is a template for the applications. Containers means, as we all know, running the applications, and registry we have warehouse of the images. For now, you can just understand in the simplest way this way. Now,
Means one question is there.
yeah.
Here, means
Mhm.
image means this image and apps means the codes, right?
Sorry, what is image?
Image like this codes, na scripts
Mhm.
or codes, right?
Okay.
Am I
Okay. You mean to?
audible?
Yeah, yeah, you're audible. You
Uh,
mentioning the which one? This one?
yes, you said images means this like templates or codes we are storing.
Yeah, basically, for now you can understand this one. This is a high level one. But
Mm-hmm.
images mean basically the something which is already ready application. Let's say you have a. Let me take an example here. You have applications, this one,
Mm-hmm.
right? What you do, this is just an application code, right? Now I want to make a
Mm-hmm.
containerized application. That means I want to make use of containerized application, or the we can call as a Docker image. For now you want to make as a Docker image. Now what you do, based on this application code, you will have to create the Docker file, right? What is a Docker file? Now Docker file contains all your setup instruction, right? Like
Mm-hmm.
you do a first A, then B, do B, then do C, like that. You will get a basically setup instructions will be defined in your what you call template. Sorry, in your Docker file. So once it is ready, then what we do, based on the Docker file instruction that you have defined, the Docker image will be created for you, or it will be built. As simple, right? So this is why, in the simplest manner, for now you can say it's a template for the application. Image mean basically it has a set of templates or basically running applications, or you can call as a containerized application.
Mm-hmm. Yeah, got it.
Okay.
Yeah.
Okay. Uh, okay. I hope this is clear. I will take back 1 second here. I will explain in the high level now. So what action. So as I told you, we have a three major parts. One is a client. Second is a Docker. Let me expand this one a little. Yeah, I hope this is clear. As I mentioned, there are three parts: client, Docker hosts, and this thing. Client is something where you actually running or you're typing your commands. Basically, let's say I want to run Docker run, I want to run Docker build, Docker pull, whatever. This all be done. But whatever you're doing, everything or whatever commands you're typing, right? They are actually communicating with the REST API to your Docker daemons, right? They are with the help of Docker daemon, and this Docker client and Docker host can be in two different locations. That means they can be isolated as well. As long as they have the connectivity, it should be fine. Or it can be in the same system as well. Okay. So what basically, as I mentioned, this the client work is to basically type the commands, and to interact with the Docker daemons, there's something called as REST API. Okay, with the help of REST API, they will connect. You can see the how it is. If you see example, Docker run, Docker build, everything is connected to the Docker daemon. So with the help of REST API, they will communicate. What it will do now in the Docker host level, Docker host work is to basically say, for example, I want to, you have a, let's say, image, we have an image registry, right? Register for a register, what basically it contains your storage basically. Now storage could be storage means it is about your, let's say, dot, you have a nginx, then you have ubuntu, then you have a postgresql, or could be any other images, right? For now you can see this is additional extension. Let's say this is a third party also, where you can also store here also. uh, we have a grafana also and other things also, like this is a plugin specific, you can ignore for now, but our focus is to basically image level, right? So basically this is image. This image also stores somewhere in a public repository in our case, right? Let's say nginx has their repository, ubuntu has their own repository. So this all store where in a docker hub, let's say in our case. Now in order to basically let's say I want to use the python application now, right? I want to use the python application. So what you'll do now, this docker daemon, you will run the commands here, right? But with the help of API, REST API, they will communicate, they will talk to the Docker daemons. Once they are able to communicate to Docker daemons, this Docker daemon work is to basically make sure whatever things should be working as expected. That means what they want, what they expect here, they expect to pull the image from where this image is going to be pulled. This image is going to be pulled from where? Registry, right? In registry, where in registry, what article they want? In my case, let's say Nginx. That means if you want to pull the Nginx, what I call images here in Docker host. Docker host something where you're basically running your things, images. Let's say you have images or whatever application. Now they will pull, or maybe based on the commands you type, maybe build min builds, they will do that one. So this all responsibility, including your building the image and running the containers, everything is responsibility by, I mean, responsibility for this particular, that is your Docker host. This particular person would be responsible for running Docker, running and building the images and the containers in your Docker host. Okay. Oh, I hope this is clear. If not, you can ask me if still you doubt, if you have doubt. You can, as I mentioned, take a look these definitions. As I told you, this same definition, I made it simple way. I have converted, I mean, I have made here so that you can see this is the simplest way to go through, because this is a huge documents. But yes, you can go through if you need at all. Okay, you can go through each one. Okay, for now, just understand this much. Okay, now next, what we need to understand here is we have understood the architecture also. Now let us understand how we can install the Docker. Okay, so to install the Docker depends on the operating system, right? In my case, I want to install in the Windows. It will be quite simple, but in your case can be a Linux or maybe any other MacBook or whatever. Let's say we are going to install in the Linux as well as Ubuntu. Sorry, Linux as well as the Windows. Now there is a documents, right? Official documents, Docker doc. If you go, you can see get started. You can also see if you want to install, there is an option get Docker option, choose the best installation path. So many supports are given. So this also we can defer. Otherwise, as I told you, you can see here, you can, if you want to go through, if you want to install something, you can do that. But as I told you, our work is to basically install it. So instead of coming to document directly, I can search here Docker, maybe I can type here. I will type Docker installation. I will not type Windows or Linux, just Docker install I will type, because once you type here, there is an option you can see install Docker engine. So now you can see here, this is where it says, right? So you can install it. Now you need to understand like your where exactly you're going to install the Docker. In my case, I want to install Linux, sorry, Windows. You may not see here, maybe, yeah, you can check below based on the your this thing, you can select one. So let's say I'll go to things first. This is for the basically Linux. So Linux, what you need to do is that you need to understand the prerequisites. Like sometimes, normally, I hope nowadays whoever using the laptop having a good configuration, but if you're using somebody very old configurations, then in this case you need to check this prerequisites also, right? You can check this OS requirement, everything. Okay, you can check other things also, but in my case, I am okay with this one, right? So first thing, install, we can install this as you click based on this operating system. In my case, it is a Ubuntu, so I selected as an Ubuntu. Now here, before you install Docker engine for the first time on your new host machine, you need to set up the Docker apt repository. That means if you're talking about the what do you call Linux, you need to take care of this also. Okay, so afterwards you can install the update Docker from your registry repository. So these are the command stream. Okay, you can just copy paste everything together and run it. So, or you can copy one by one, like what will do first. If you can see this here, right? Add Docker's official CPT. Now here they will first update, then they will install this thing called using, they'll install then these particular things, they will call it, then they will give permissions, then they will add the repository here. So this is all. You don't use the ChatGPT or anything while installations, because this is something shared by the Microsoft, I mean official documents of Dockers. So you try to follow the official documents for installation. Okay, once you're done, now you can also, if you see here, install the Docker package, then only you are going to install a Docker package. If you want letters, you can select this one, copy paste, there is an option to copy. And if you want to select a particular version, maybe you can select according to your requirement. But in my case, I'm going to go with the default one, I mean latest one. Once you're done, maybe if you want to test, you can test it. So as I mentioned, I have already done this one. So nothing to show here. But if I want to, or maybe still see, I can just run these commands, copy this one. Maybe I don't know if that works, but I can show you. As I told you, this is a I have installed in my local system. This is part of your system only. Okay, now I can simply run these commands. Right. If you run these commands, now I can check. It is asking the password. Let me give password. So you can see, I just copy pasted. You should not be thinking much what exactly this thing, because this is all given by the I mean, official documents. So you can check everything. They are going to take care everything. Okay. So it is done. Reading the package list, it is completed. Once it is done, what you can do, you can go with the now I can go with the installations. I can just select this one. I can okay, because as I told, it is already installed, so I'm good here. Now I can check here Docker running these commands. What is it? This basically verifies the installation is successful by running this one. So I can run these commands also. Let me run. Sorry, I think I typed something wrong. If you want, you can type manually, or you can maybe just do it accordingly. Okay, I will run. So now I can see. Now, if I want to check this thing, I can maybe run Docker images ls. Sorry, it is ls. It is Docker spelling is okay. Okay, permission denied. No problem. I'll give permissions using sudo. Okay. Now, is it ls ls again? Image not found matching. Images okay. ls. Where is the command? I use something. Why? Did you mean Docker? Did I say the spelling wrong? Spelling is correct, right? DOC can Docker. Yeah, now it's coming. Some I think spelling mistake. Okay, ls came. Now you can see the hello world. This basically you can see the latest. This is basically the repository, that is the hello world name, hello repository name, and this is the tag for each one. You can have a tag created, and this is basically the image ID, and this is created when it is got created. This is, as I told you, this is all from the repository, right, directly, and this is the size of the Docker image basically. So you can see like that. Okay, now we have installed it. Same way, if you want to do it for the Linux, sorry, Windows is quite easy as compared to Linux, right? So in the Windows case, what you need is simply type here Windows. You type, and there is an option install Docker desktop on Windows. You can select this one. Uh, in my case, I have it already, so you can just install the latest one. You can see by default, right, based on your requirement. Maybe in my case, I will be choosing this one, Docker desktop for Windows 64. Okay, so I have already done that. I can show you. If you see here, Docker desktop is created already. If I open here, you need to have this one. The reason because you need to keep the my case. So I have always signed it. So you once you basically create this thing, you can see here, right? I have created my ID also. This is basically the you need ID basically to store your images, because you need to pull the images, right, while working with Dockers. So I need to have the uh, account also. That is your Docker Hub ID. So you can type Docker Hub login. So why we want Docker Hub ID? As I mentioned, we have a component. We'll discuss that later. But for now, understand that to store your images, basically, like whatever you want to containerize the images, those images will be stored somewhere in your centralized location, right? This is why we need it. So in my case, I have it. It is my email ID actually. You can give gmail.com. If you are new somebody, let's say, you can choose basically you can log in with different methods. If you are doing for the first time, instead of sign in, you can do a sign up. But in my case, I have already done sign up, so I'm signing in. Okay. Now I can type the password. Maybe I don't remember the password. Let me try. Okay. Okay, forget about this one. I forgot the password. I don't know what password I given. Anyway, I have already logged in before, so I don't need to log in again. Okay, try to log in with the proper password. So once you log in, this is where something you can see something like this. Okay, Docker Hub repository. Now these are the repository before I tested. Okay, this you can also post something like that. You can see different repository 1 year ago and all that. This is all old account basically. So same way you can do it. So as I told you, you need to create sign up first, then you can post it. I will show you how to do this and all. For now, just understand Docker Hub is something to basically store your repository. Docker image basically, I mean to say. Okay, good. Now we are good with this one. We have installed. So in installation for Windows, as I told you, click here, next you do. Then you have to log in with the proper credentials like that. Okay. And if you want to see the complete steps, there is a in my YouTube, I have already created one this thing also. You can check there also how to install a Docker. You can get a proper idea maybe there. I'll just show you once. Okay, so if you go here, so yeah, so if you go here, there is a Docker right here. Here now you can go here like how to install right there number 2. So even you can check that there number 1 also. So every steps are given here. I can go through this one also once if you have time. It will be a installation part. Okay. So it is very simple. Just click here, next. You do configure it. That's it. Once you do complete this one, you also need to be take care of this also. You have to use the this one, not Hyper-V. Okay, use this one. Then you can go through the documents also. As I told you, automatically when you install, they will suggest you. You just need to select the right one. That's it. Then you don't need to run any commands. That's it. Just installation is done. Okay. So okay. In my case, we are good here. Now what we will do once we are done with the installation, now we'll try to see the commands basically. The first one, where is my code here? Components. There are so many components we have, right? So we have understood how to basically install the Docker also in Linux as well as Windows. So it is very straightforward. You can just refer documents. That's it. And the first thing, we'll understand the components that is your containers. So containers already we have discussed. It is basically lightweight, isolated environment that package an application code, runtime, system tools, system libraries, and settings. That means whenever I say the containers, it's basically isolated environment that has your applications code, runtime, system tools, and everything, right? So why we need that one? Because if you want to run your application, right, because our application will be running in your container, right, within the container only your application will be running, not on your particular any kind of Docker or anywhere. This application, let's say you have a .NET application. If you want to maybe run this application, actual application will be running in your container only. But in the container where we will discuss in the container later, we will discuss in details. For now, understand that the application will be deployed in your container or running in your container level. Okay. Now you can see also best practice, aim for single responsibility for principles, encapsulating each service or application in its own container for easier management or scalability. So as I told you, you don't need to know this here, just understand these definitions, the high level. Okay. Now same thing, we have a Docker engine. Docker engine is something that we have already just now was trying to understand that one. The core engine responsible for building and running container. That means Docker engine work is to basically what building and running the containers. That means we have the thing, right? So we'll understand this also. So whenever if you don't have a Docker basically engine install, then you cannot. Docker engine is nothing but whenever you install the Docker, it is as simple for now. Understand, whenever you install Docker, let's say in my case, I have installed Docker. Now I can also check if I want to check. How can I check? Docker double dash 7 dash. You can use the version, right? So you can see that this is the Docker version is used now. So as you once you're done with the installation, that means your Docker engine basically been set up now. Okay, that means now what is the work of the Docker engine? To run the basically once you install the Docker, then only you can basically run, I mean you can build and run your containers, right? So basically you need to run different commands based on this situation. So we are good with this one. Then we have Docker file. Docker file is also components basically in your Docker. Why Docker file is required? Docker file, a text file that contains instruction for building a Docker image. It specifies the environment and commands needed to run in applications. So Docker file means, let me just take you one step further. I can assume Docker example. Okay, I think I have it here. Let me check. Yeah, I have here. Oh my God, this is big one. Let's not take the big core. I will take the small one. Yeah, I will take this one. Okay, so what first, if you see the definition, Docker file is nothing but it has a set of instructions. What kind of instruction it has? For building and running the application, right? You need to basically define certain instructions, right? Let's say if you can see here, for building Docker image, right? You need to have some. It specifies environment and commands needed to run an application. That means with whatever you want to do, there should be some instructions in order to complete the task. Same way, let's say I want to build these applications, right? If you want to build this application, I need to have the set of instruction defined here. Like first you do A, then do a B. That means why we require that one? Because each application would have their own dependency file, right? So we need to understand that point of things, and accordingly we need to define as a instructions in your Docker file also. So if you take a look here, Docker file, as I mentioned, is nothing but it is a set of instruction, right? So now what you see here from, whenever you see any Docker file in anywhere, right, you would see first from. What is a from now? If you take a look here also, the first thing you can see a from, right? From is something is must. Here given this part. Now if same way, if you see here from they given here. What is a from now? From is nothing but base image. Now what is base image? Base image nothing but origin. Now origin is nothing but from what exactly from where the image is going to be pulled. Basically you need to define, right, that. So this is the reason why from is something nothing base image, you need to define it. From, in my case, the base image would be a Python, this particular version 3.12. Then once you basically pull the or get the images, the base image, that is a Python, then what they will do, work directory or working directory, they will create. Once you get this repository for now the thing, or this is basically a base image. Once you have a base image ready, you will have to create a folder also, because I want to store this particular this thing also, right? Basically two components. Let's say I want to run these applications, but then to run this application I would be needing a lot of dependency file, right? So to store this dependency file, where can I store? This is the reason why there is another instructions or commands, basically commands where you can set. That means once I get this thing, please make a directory or create a directory called /user/local/app. That means in this particular directory or this particular location, make a folder called app. Okay, that they will create here. Once it is created, this directory, what they will do next, install the application dependency, because as I told you, this is for the Python would have a dependency always file there, something called as a file extension with requirement.txt file will have it. So this is where they define all the application to run this particular Python applications, whatever the dependencies files are there. So you need to define the commands, right? These all commands will be defined here in this particular file.txt file. Okay, they will define here, then they will copy you with the help of copy, because once you switch to this particular directory with the command what is instruction of the command copy, they will copy. There is a file call or this particular name, they will copy to where this particular location they will copy now. Okay, so that means this particular file, once you copy, will be stored under app. Okay, then once you have everything, all the prerequisites or maybe commands ready, then what they will do, they will run. This is also another instructions. This is for your what, running. Once you copy, they will run, right? This is a Python, they will install it, and then checking this particular part, this is nothing but this one, so they will run this, they'll install. That means whatever commands I have within this particular or inside this commands.txt, I mean requirement.txt, will be installed accordingly. So once you're done this thing, second, I mean here third, copy in the source code, because it is installed where, in your local, right? Now this need to be copied in your source code. Now this is the reason why this is another commands basic or the instruction, they will copy to where source. This is a short form. src is nothing but source. In the source code to where, in this particular directory, they will also expose the port. What is a port for this one? This is basically the application port or container port basically. Okay, because container is something, as I mentioned, it is a lightweight isolated environment that has your packages, application core, system libraries, everything it has, right? So in order to run the application, you also need to expose the application port number also, right? So that it can work as expected. So this is the reason you also need to expose. Once you done expose this thing, then what you do is that set up an application, so the app user, so the container does not run as a root user. So this is actually optional. That means this particular application, once you build, you would not basically run as a root user. As we all know, root user is something that is basically has a high privilege. That means you should not, everybody should not have access to root user. This is the reason here. This is also possible that you can define, I can run another command using the run arguments or instructions, right? So this time at user add is nothing but it is again Linux command, right? You basically, it is going to create a user with the name of app, and then a user given this name. Okay, now they will run this thing. So now they are exporting the port, this particular port, everything. Okay, that's how that means now you can see, right? So in order to run just Python, small Python code, there is so many instructions. What is the first, you can do A, then do B, then C, like that. All the instructions are defined as a commands in your Docker file. So this is why I say Docker file is nothing but it is a plain text that has a set of instructions. Now set of instruction, as we all know right now, that means you have a, you can first get a base image, then you create a directory, then you can copy the requirement files, then you can install that one, then you can copy the source file, then you can expose the port, then you can set a user and then run this thing like that. They will be giving a set of instructions, right? This is what we say, it is a set of instruction defined in your plain text. So this is by, it is very self-explanatory, by seeing you can understand. Same way, if you talk about the real time, that is your .NET based applications. As I mentioned, base image is something always must. So whenever I want to create as a Docker, Docker image, so you can see, right? First, from in first I have to get a base image from this particular URL as a base image. Then I will create a directory called as a this particular, then I will expose the port. I will set the environment. This is optional, but yes, you can define if you want. Then use the SDK image for building the applications. You might be thinking here, I have given multiple times the from image from, like this is a, if you see here, from here also from, and sometime you may get to see even here also from. Why are we using a from multiple times? That we will understand in coming days. Okay, for now understand in this high way, in the high level, we are going to do this thing, then we are going to expose, then we are going to do everything. Because if you see here, why we are using multiple time from, if you see the part of the base image, it is taking this one, whereas if you see here, this is taking another this thing, this is for a building time. So the reason why we require here is that if you define, if you see, I can use same as this also, but problem here is that if you have a multiple like if you have a Docker, this kind of images, right, you cannot directly copy entire application code, right? So what you need is maybe only the code that I need, I will be copying, right? This is the reason why I'm using multiply from base image. So I would be only copying something what I need. I don't want to copy entire application code or maybe entire dependency file. So depends on the requirement. In order to make your basically image smaller or lightweight, we can make use of multiple from, like you can define like this based on the requirement. So as I told you, this is a set of instructions. So as you work, you will get to know everything in details like this. Okay. So for now, just understand this much. We have a session where we discuss and write everything from scratch. Okay. Now, okay. Now we go with the Docker image. We know now Docker image basically a lightweight standalone executable package that includes everything needed to run a piece of software, including the core, the runtime, libraries, environment, variables, everything. That means Docker image is nothing but it is a lightweight standalone executable package. That means whatever code we have here, instead of defining the, because if you see here in this particular repository, I have so many code, right? So what they will do, they will make this one as small as possible as an executable format so that they can deploy anywhere. But then whatever the packages, I mean application, you need a dependency file, right? It will be read basically as part of the Docker image. So that instead of, if you see this one, it will be more than a 2-3 GB also. But when comes to this particular Docker image, will be very smaller image size. Maybe if you want, you can see once as I shown also. You can see one example I shown you. This is the only this many size. But if you talk about the entire repository size, it will be bigger one, right? It will be more than a GB. So this is the reason why we can make use of the Docker image. Now we understood, right? That means Docker image has a the kind of facility or maybe the this thing advantage where it has all the piece of the software and including your system code, library, system, everything it has, including configuration file. So we can deploy wherever you want as long as your environment is ready. As I told you, this Docker image will be deployed to where in your container basically. So Docker containers, an executable instance of Docker image. It encapsulates the application and dependencies running an isolated environment. So we all know, right? So it, as I mentioned, we have discussed this also. Now Compose. Docker Compose is something, a tool for defining and running multiple containers, Docker applications. It uses YAML file to configure application service and their dependency. Now, what we need to understand here is, say for example, if you notice here, I have only one container running here. If you want, if you can check, maybe you can type Docker PS, right? Docker PS, basically, I don't have anything right now. That's why maybe I will give permissions. Now I don't have anything running. So Docker PS nothing but basically it will show you the running containers. In my case, I don't have any running containers because this is a new system. I will show you in some time. Okay. So right now we don't have it. So basically, let's say if you have one containers running right now, let's say you have a one container is okay, you can manage it. Let's say normally in your any organization, right, you have a more than maybe 30, 50 or 100 also, right, containers running. So how are you going to manage all of them? in one go, right? You cannot manage them separately. Let's say one of the container goes down, or one of the container you need to restart, or one of the container you need to update something. So how can you make how can you ensure that you can do that? So this is the reason why we can make use of Docker Compose. Okay, then we have a Docker volume. Docker volume, basically, as name suggests, volumes mean we all know, right? Persistent data storage for containers. Decoupled from containers lifecycle, volumes allow data to persist between container restore and migrations. So volume means, for example, what basically, let's say in a container we have data, we have a different kind of data, systems, code, everything we have, right? So basically, where are you going to store? Let's say your container goes down, your container got restarted, or container got killed, or for any reason, right? So your data also get crashed, right? So you may lose the data. So in order to avoid this one, if you don't want to lose the data because it is running in the container, of course, if you run the containers and your container got crashed, something happened, you will lose the data. To avoid that one, so what we can use, that we can use something called Docker volume, basically. So that will be isolated. You can create a separate Docker volume and attach to the container, basically, so that you can, if let's say your container goes down also, you can still basically attach the Docker volume to another container as well if required. Okay, then we have network. Network, basically, mechanism for container isolation and the communication. Docker and network Docker network enables containers and communicate with each other and external network while providing network segmentation and access control. So whenever I use a Docker network, or whenever I basically install Docker, let me show you. If I type simple here, it is asking them password. Okay, let me just type password. Sorry, 1 Okay, I will okay, let me say Docker, Docker network, right? You can see, if you type Docker network, these are some of the commands that we need to understand. I just type Docker network. So manage network, if you want, there is a commands. If you want to connect to a particular network, you can use a connect, like Docker network connect. Same thing, if you want to create different network, you can create a Docker network, then create. You can see definition also, create a network. Similar way, if you want to disconnect, let's say from particular network, I want to disconnect, then you can use the this commands, disconnect commands. If you want to inspect something, nothing but it is basically details information about a network. And if you want to list the list of the network, you can do that. And if you want to remove all unused networks, if you have something like unused network, you can like use this command, prawn command. rm basically remove one or more network. If you want to remove the network, you can use this thing. So these are some of the commands that you can be exploring. Okay, now if I want to, as I mentioned, according to this one, I want to list, right, list network, I can use the ls. It is actually permission issue. Maybe I need to give a sort of access right now. So what you notice here, whenever I run, whenever, if you see here, there is a network ID. This is basically network ID. For each network would have a network ID, and this is the name of the network, and this is the driver name, and this is a scope. So what we need to understand here, first thing, network ID is something we are aware, right? So basically for each network would have a unique ID. We all know that. And now within the name, if you notice, there are three network ID name. Like one is a breeze, host, and a non. What is breeze? What is host? What is non? We'll understand. If you see the driver level, the breeze nothing but breeze, and the host mean host, again non mean null, and is the scope level is a local. What is all this about? What is basically we need to understand here is that if you're coming to the point of network here, where is that? Okay, so I think that is the network level. Let me check if I have this one. Um, yeah, yeah, you can see here, right? So You can have a look like this one. Let me check network demons. I have mentioned somewhere actually. Let me check. Yeah, bridge network. We can see bridge network. By default, this is a default network, and then we have it host network, right? Host network. Here also you can see host network. Host network. Then we have a non. Non is nothing but for now. I don't need to think much because it's nothing much to explain. So these two need to understand bridge and a host. So whenever basically you're creating a Docker, right? Whenever you're creating Dockers, by default, the bridge network will be created for you. That means now if you see here, even if you see the high level here, you can see here networking part, Docker, I think here, right? Creates a virtual network bridge that is a Docker D. I will show you this also later how we can see this thing. On the host machine. Host machine means basically this is the host machine where we have installed the machine, right? So they have this is the default network as I mentioned here. By default with this name, it will come. Now the bridge act as a central hub for container to connect and communicate using private IP address assigned by Docker's internal DHCP server. So container can access the host network and the internal if allowed. So by default, basically this particular network that is a bridge network would have a communication between external and internal. Okay, but IP will be assigned here, and this particular this thing will be used with this name that is a Docker D. This is the Ethernet name basically. I will show you on, maybe later. You can see this thing. Okay, so you can check this also. Okay, so similar way we have it the Docker host. You can take a look. Removes network isolation between containers and host machine. That means here means the containers and the host machine would have a isolation. They will have a isolation network. They will not have the communication between host and a container. But whereas in the bridge network, it has a communication between two network. Here it will be separated. It will be isolated basically. Here containers share same IP address and network configuration as the host, allowing direct access to the host network resource. Okay, don't worry, we will have a session. I will demo later. I will show you that one. For now, just understand in the high level. Okay, okay. Coming to the point about the this one, right? Now, okay. So what we will do? So we have understood the components, high level, small components, right? Whatever we have come, we will try to understand some commands now. So what we will do? We will try to use the Docker pool. These are some of the commands that we can explore it. I will try to maybe explain some of them. Let's say I will use the Docker pool and an image name. The pool and image from the registry. Registry is, as I mentioned, it is basically a repository where it stores your Docker images, right? In your public repository or maybe private repository. Now, in my case, we are talking about the public repository that is your Docker Hub. I think here, right? Yeah, I think I have it here. Yeah, I'm talking about here. This is basically Docker desktop. Here I have login already. So this is basically I have login to the Docker Hub. Maybe if you want, you can also log in. There is a directly you can access it. Docker Hub. I forgot my username, so but maybe I can just try to log in. Let's see. Mm, Hriyen. Let me forget password. Okay. Reset password. Let me change the password now. S1 one. S144 okay. So I have yeah, I have resetted the password. Now let me refresh the page. I can now log in. Let me 1 second, Docker. Now I can type the same password, I mean username, Hriyen Tripura, gmail.com. Okay. You can create it. There is an option to create also sign up. So I will type the password. Now I have reset it. Okay, so good. I will save it anyway. I don't need much. Now, if you see here, I have so many repository. This is also same thing. If you log in here, Docker or like here also we can see, right? Like whatever we have here, because this is logging with the same ID. That's the thing. Okay. So whatever you see, this is from Docker locally, but this is from the public cloud, basically cloud in the sorry, public network, public repository. That is a Docker Hub directly from Docker Hub. So I have the ID, so I can see this many. So let's understand first coming to the commands, right? The first one will try to run Docker. I'll close this also. I don't need that. I don't need this also. I don't need this also. I don't need, yeah, I will come here. So now what we will do, first we will pull the images, simple image we are pulling now. Okay. So now what we'll do, there is a pull. Let's say there is a command, right? First what I'll do, with the help of Docker pull, what it'll do, it is going to download this thing, right? In my case, I'm going to run these commands. That is a Docker pull, then Ubuntu, and this is a tag name. I will just click here. Let me run here. Let me clear the screen first. Let me run here. Okay, what I'll do, first thing what I'll do, whenever I run for the first time, right? Docker pull, this is the name of the image basically, in my case Ubuntu image, and with a tag name, that is the latest tag. That means whenever I pull, what happens? Let me show you. Just enter. Permission, okay. Maybe I need to give a show of permissions. Just notice, okay. So now you see. So as soon as I basically run with Docker pull and particular image, what happened basically, they will check this thing, latest code. It is going to pull from where? It is going to pull from library under Ubuntu. And basically what is this one? Actually this is a repository, right? Which repository? This is a GitHub, sorry, Docker Hub repository. Now let me close this one. Let me take you. If I click here, Ubuntu, right? Or you can just type. If I go here, where is that? Here, right? Let me search here. Under here, a repository, all repository. Let me search here. Not here. Public repository here. Sorry, here, right? Not in my repository. This is taken from this thing. Now, can you see here? This is coming here. Now, let me refresh this. Click here. That means this is basically, as I told you, this is in your publicly available repository. So I have clicked it here. So as I click here, this is, if you see Ubuntu, it is a Docker official image. This is basically Docker image, okay? Ubuntu image basically. This is Dockerized now. Now, if you want to pull, as I told you, this command be used, right? And we use a tag. So you can see here, Docker pull, basically pulling the images from your registry. That in our case, it is a Docker Hub registry. Okay, so Ubuntu we use it. Now, if you see here, there you have so many tags. Now you can see the latest and everything. Now there are so many tags. Depends on the thing. If you want to, if you, in my case, I selected as a tag name as latest. In your case, maybe if you want to select particular different tag, maybe you can do so by defining the tag name. Okay. In my case, I selected latest. That is why. Now, what we need to understand one thing here, as I told you, these are the tag supported tag. You can also go through this one, official documents. Next is if you click the tag, These are a tag created for different tag, right? So as I told you, you can get if you want to select whichever tag you can particular image if you want, you can select this one, copy paste it also you can do. Now this thing we understood. Now if you coming to the here, now as I told you, this is from where, this is all coming from your official basically Docker Hub, right? This is from there, this is coming. This is why I'm saying it. So whenever I run locally these commands using the Docker pull commands, it is going to first check locally if they have, if you don't have this particular repository, sorry, images, they will directly pull from the library, and that is your repository, that is GitHub, sorry, Docker Hub. They will pull it. Once you pull, there will be, this is basically ID, basically this ID, you will get it, the image ID, and they will pull the pull complete will happen. Okay, that means your pull successfully will be done. Then this is the ID, and then they will mention here status downloaded newer image for a particular. That means now this is the name. Now we'll be able to see now. Now if you check, how can I check the image of this particular? Now what we did was, we have simply basically pulled the images from your registry file, that is your Docker Hub. Now let us see the image. How can I see? So I can type Docker images ls. Spelling wrong. Is this ls or something? I'll copy from this. Sometime while typing, I don't know why it's coming like this, but yeah, I'll copy from here. Okay, now we will copy. It's not mentioned ls. Okay, image is not this thing. First, I will run this thing, then Docker ps, whether it's running. Now, as I told you, no, sorry, still permission issue. Let me give the permission. In my case, as I mentioned, it is not run still. It is basically empty one, right? Empty basically Docker is now. What I need first, then next, let's go with the first. I want to see the images available, right? I don't want to give the ls. So in my case, maybe I try with the ls. That is why it's not showing. So you don't need ls. You can run directly Docker image command. So in my case, what I can do, I can run the Docker. I don't need ls. Network be needed. So Docker images. Why is coming? Let me check. Okay, Docker. I don't know why what is the spelling mistake here? Docker doc, okay, Docker images dock. Oh, spelling wrong here. Okay, I did a wrong spelling. Anyway, so now you can see, right? Right now we have two repositories. Remember, first we did was this one. We basically download the latest one during installations. This is the thing. Now second, Ubuntu latest stack with this particular image ID, and this is the created 2 years ago, because as I told you, we taken the latest, right? So every single images would be updated based on the listing new tag. Okay, changes they do. So in my case, it is the size is 78.1 MB, right? So that's how it is now. So now the images from your Docker Hub. Now what we will do next, we'll go with the according to this one. If I want to run this thing, what I can do, I can run this particular name, like you can run the Docker run image, run a container based on the image. That means we have Ubuntu. So what we do, we'll go here. Now we will follow this one, running container, run the container, execute Docker run, as I mentioned, with the Docker image, sorry, image name means whatever image name, and to start the container. So first thing what we need to understand here, Docker run basically running the containers, right? Now we have the this thing, double dash name. What is this thing? This is nothing but your image name. Basically, name is nothing but image name. Whatever image name you can give, as long as you name you wish. Okay, so I can give a name, image name as Docker, basically Docker image name, this one. Okay, I given as a web app D dash D and dash D. What is mean D? D mean details mode. Okay, details mode, there will be a D. You can also search if you want. For now, let's not go that details. D mean details mode and T mean terminal. Okay, and P mean port, P-O-R-T, port. So basically Ubuntu, basically what is going to happen here is that I'm going to run the Docker image with the name of this image name from this particular image, that is a Docker image base, and I'm going to pass details mode. Why I want details mode? If you want the attach mode, mean basically what happens, you will be always in the particular mode only. If you cannot come out of that, that means if I run the details mode, I can run this particular Docker image in the background. That means I can actually work some other tasks also if I still define here. If I don't define here, it will be in your within the screen only. That means I cannot. You have to come exit. I have to come out of that. Just like a Linux, how we try to modify some file within the file, right? I mean within the file, trying to modify something, right? We have to come out of that to save it, right? Same way, even in Docker also we have this option like this one. So if you don't want to that happen, you can use the details mode. That means there are port. One is a local port. This is a local. This is a local. This is a container port. This is a local port. One is a local port. This is a container port. Because container port and a local port need to be exposed together. Now let me run this one. So as I told you, first thing I have done with this one, let me do second one because we have the image. Now image is taken from where? Image is already got from the locally. I mean from here it is there. I believe this image is already defined, right? So now I'm going to run the Docker image. In my case, I given an image name as a web app. I can give any name, right? Whatever name I want, Docker image name, I can give it. This image will be created based on what? Based on this Ubuntu. Now let me run this thing. Sorry, I'm always trying to define without sudo command. Now you see. Now what do you see here? As soon as I type here, this if I type here, this name come. What is this actually? Let us see. How can I check this one now? You can type. This is a container thing, right? If you type here, Docker PS. Sorry. I need to give permission for this one anyway. Now you see. Now, if you see here, as I told you, we have taken whenever, if you remember, while running the container Docker this thing image, building this thing, we took this Ubuntu image, right? And we given the image name as a web app. Then it is got created accordingly. Now, whenever I run Docker PS, nothing but I want to see the running Docker containers. If I use this one, Docker PS means running container, I can see here. That means, as I told you, container is created. Now, whenever I run the PS means, as I mentioned, PS something to check whether containers are running. Now, as I mentioned, we have a container already. That is the container ID. And this is the image. Image, as I mentioned, we are taking the Ubuntu image. If you remember here, right, we take Ubuntu. And this is the location by default. And when it is got created, this container got created 23 seconds ago. That means just now. And status up to this many second. And what is the port we given? In my case, as I told you, one is your local, second is your container port. So in my case, TCP. Now if you see 80, this is your local, this is your container port, TCP by default. Whatever name I given, in my case, this is basically, what is the name? This name is nothing but a container name. It is not the image. Okay, this is a container, basically container name be given as the image, container, whatever name I want to define. Now I can see that it is running, right? You can see here. Okay. Now what we can do, let's see next. Now, if you want to basically go with this thing, explore the container run Docker exec. Basically, if you want to within a container, as I told you, this is a container, right? If I use the Docker exec and IT is nothing but interactive terminal. That means if I want to go inside the particular container and run some commands, then I can run this command .exec, then interactive terminal, in particular container as a bash. Then I can go inside. Now if I type here, let me enter this one. Okay. Sorry, my bad. It is not copied properly. Okay, now what will happen, see here, just notice here I'm in under Hriyen in this particular this thing. Now let me go inside. Sorry, permission again I need to give. Okay, now you see, can you see where I am now? Before typing here, I'm actually inside my system in this particular directory. Now if you see here, I'm inside root and third distance. What is this actually? This is actually a container. That means you are not in your system or Docker host basically. Right now you are inside your containers. Let's say if there is any issue, if you want to check something, maybe you can run the commands here. Now if you want to run some commands inside here, maybe you can type ls, you can check here, right? Because I'm inside this thing. But one thing we need to remember here, whatever commands you are typing within your container, every single command will not work as expected. You need to install them manually. Okay, so that is a thing. Now if I try to maybe say let's say time, I can see a time. um, Time in what is it, time date or time, just I don't know. Let me say time there or something. Okay, I'll just type date maybe, otherwise, right, we can share date. So whatever you are doing, actually, this is doing within your container. This is the reason why you can see the container ID. If you see, how can I confirm this container ID is correct? What is the last number? It is a start with double B, last end with 4D. If you notice here 4D, you can see, right? Container ID. You can check. Can you see here? This is the same container ID, 4D last number. So this is how we can export. Question is, why do we need to go inside a container? It depends on the situations. Say for example, this particular applications where you have deployed the applications, maybe it's not working as expected or something issue, some issue is there. You need to check them. Then you can of course use these commands. I mean, you can see, you can check the memory. That means I can check within the container only, not in your this thing level. Okay, now I can see everything. So you can run so many commands according to the issue. I hope this is clear. How can I come out of this one? Just like a Windows, Linux, I mean, you can just use a exit command. Exit to exit from the container. Let me exit. Okay, now you can see I'm back now. Okay, I hope this is clear. Now let's go next one. That is about, yeah, exit is okay. Now creating custom image that we understood. Now I will try to, whatever we have done, we have seen some of the things. Now I will try to run some of the commands so that you can get some idea. Let me run. Basically, as I told you, if you want to see the Docker image, I can simply run Docker image commands. So this one already we have Docker image, right? That is a web app. Something we given some name. Let me type here. Let me type sudo first. Sorry. Okay. Now you can see the image. As I told you, there is a Ubuntu image and there is another one hello world image. So I have two images. I can see with the help of Docker images. Okay, not image, it is a S is there. Okay, images. Similar way, if you want to run, I have always shown how to run this one containers. I can give full path, and PS mean to list running. This means only the running containers. Running containers means right now I have the Ubuntu applications running. I mean this thing, right? Web app running. Now if you type here same thing, sudo docker ps. PS mean, as I told you, I have this web app containers running right now. So this is why showing. If you don't have, we can have. You don't need to. In my case, I have it one. Now, if you want to see list all container, including stop. Including stop means do one thing. I will create one more container. I can show you that also. Maybe what I'll do now. In this case, web app, I will change this in. Maybe I type as your Nginx. I hope spelling is correct. I given the same name just for our understanding purpose. Nginx. So what you need to understand here, as I mentioned, first whenever you are run the Docker pool, by default they will check, Docker will check locally whether your images are able to find or not. If the images are not there locally, then only they will go to the specific repository and pull the images. As simple, right? That is your registry. So if you notice here, I try to pull the images. That is your Nginx, right? Nginx I want to do. Unable to find image, this particular Nginx latest locally. That means, as I mentioned, they'll try to pull the images or find the images locally. If they have locally, then they will not get from the repository or registry basically. But in my case, this particular Nginx was not there in the locally. This is the reason why they are pulling the from the Nginx directly here. Now, if you go here, same just like how I shown in the here, you can see here. Search again here, Nginx. Now you can see this is all the image ready. Now you can see here, same like that. Go through everything. Okay, same like that we have done it. So that is why it is not a locally, then they are going to pull the different version. They are pull everything completed, then it mentioned it is got pulled this name latest. Now you can ignore for now this one. Now what we will do, let us see how we can see the Docker image now. Again, as I told you, Docker images, because we have now 3 images, right? We let us see that one. We have 3 images. So sorry. Right. Now we can see the 3 images, Ubuntu, Nginx, hello world. Right. Now we understood till now, I think. Now we have 3 images. For each one would have a different size. Depends on the image. Now, what is our work? To basically same like Nginx, I want to create the container. The reason why I want to create a container, because I want to show you something. Okay, my bad. Now same way, what I'll do here, if you see here, be done these comments, right? Then I will be basically exec. I don't need to exec. Now fi1 ps, because the container is running, Nginx container also running. Now we'll have a 2 containers running. One is your Ubuntu, that is your web app. Second is your Nginx, because the name be given as a name be given as Nginx. If you type ls, sorry, ps, you can see here. My background is okay. Now we can see here. Now okay, maybe there is some issue while pulling it. Let me check. Engine Docker. Okay, I got it. Why it's not working? I can change this thing. I can change, because the port cannot be used same port. Always try to remember, locally can be unique port should be used. This is a local port, this is a container port. If you're using the multiple containers, try to use a different port. In my case, I can add one more 0 maybe. Sorry, 1. In my case, I can change the name because its image got created. So maybe no problem. I can change Nginx one. Okay, I will change this because once this name is created, this is the container name. You cannot have the duplicate name, because this name already was created. This is why it's not taking. I given a different name, and from the Nginx. So in my case, same thing. For particular port also, I need to be changed. This is a local port. This is a container port basically to expose it. So I am running it now. Now we can see here. It is success now. Now if I type the Docker PS, I can see now 2 images going to, sorry, my bad. Let me run the sudo. Okay, now you can see 2 images. The first one is your web app. Second is your Nginx 01, because this is a name we given. The first we created was not working because there is some conflict with the port number. Now, if you see here, You can see the port number. This is a local port. This is a container port. So container port always can be same, but then the local port, what you're exposing should be unique. Okay. Same thing. The image name should be unique as well. For each container, image should name should be unique. Now we got right. Now you can see the ID also different. And this is from the image from the Nginx. This is from the Ubuntu. Now we have understood. Now that means I have two images running, right? Containers running basically. Let me stop one of them. If you want to stop, how can I stop that one? Let us see. Now, as I told you, this command basically will list you everything that is required. But if you use a dash a, it will list even the stop also. Now, but if you type with the docker ps dash a, still I can see, right? I can see here hello world ubuntu image everything. I have so many, right? So web everything. Now this is all including everything stop and running containers. Now, if you want to stop, you can use the stop command. Docker stop container name. Stop running container. That means right now, let us see how many containers are running. As we all know, this is the command we are using. Right now, we have two containers. Let me stop this particular container. That is the web app. What is the container name? This is the container. You can call with the container ID or the name. Depends on that. Now, okay. In my case, okay, let me go with the container web app name. Maybe I can type container docker stop permission deny. Okay. Hello world. How come this is name? Uh, web web. Okay. Web app. I can go sudo
Hriyen, give
rm
sudo hyphen I once so that it always stays in root
one
user.
which one sudo.
Give run a command as sudo
Oh,
space
sorry.
hyphen I.
No, no, my bad. There's a common mistake. Yeah, that's also okay. It's okay. It should fine. It should work. So it will take maybe at least second. Okay. So as I told you, while stopping the container, running containers, you can call with the, as you can see here, it is stopped right now, right? It is successful. And this name you can call, otherwise you can call with a container ID also. So both works fine. You can call with a container ID or a container name. Depends on you. If you have a similar name, try to call with the container ID otherwise. Okay, now if you type again, ls docker ps, if you type, because as I told you, ps2 basically lists all the running container. In my case, I have stopped the web app. Now only it will show one. Sorry, again I'm trying to forget that. Sudo. Okay. Now you can see only this is running because this is stopped now. Now, now as I told you, if I want to list everything, now I can see that's right. So I can see everything, including running or stop everything. Now we understood right how to stop it. Now next we'll how to start this thing. Same container we need to start. That means instead of stop, just start you do. So let me start again. Stop Jaga start. So it is very simple. Only you need to remember Docker. That's it. Just start, stop like that. You can see the container name. It is start now. Now if you do PS, only the running, you can see it is running now. If you see the date, status, it is just 5 minutes ago. Sorry, 5 seconds ago. Web app, right? So that's how it is created. It is many ago, but it is got status is up just 5 seconds ago. Okay, next, if you want to restart, you can also same like that, just like that. We can try now. If you want to remove the stop container, now this particular this thing container, if you want to remove in the sense particular container right now, you can see two containers running container cannot be stopped directly. So if you want to stop the container first, I mean remove the container, you need to stop the container and then only you have to remove the container. So but if you want, you can do so forcefully, you can do that. So let us see that. So if you want to remove, so as you can see your comments, you can follow this one, right? Containers, if you want to stop, you can use this name, rm. Now and container name. Now rm means same like that. If I want to run the same commands, rest of I can use rm, basically removing it the running, because this is already running, right? Now you can get an error. You can see here error response from daemon. So if you remember why daemon is used, now you understand, right? Daemon also is responsibilities to take care of the containers and the image everything. So now they are saying from the daemon, they saying cannot remove container, this particular container name, container is running, stop the container before removing the or force remove. As I mentioned, if you want, you can do a force remove, or you can stop the container first and then remove it. So either way you can do it. So in my case, as I mentioned, stop we can do it. We can stop the container first. How can I stop again? Same way I can stop. Okay, stop container. Now I can remove it. It is just a small command, right? Just stop docker rm stop like that. It's very small commands. Now next, let it stop. Now I'll try to remove it. This is the command I use. No, now I will try to remove. Now it should be removed now. See, it is gone. No issue. Now if you type here again docker ps, you can see. Sorry, I have only one, right? Um, yeah. Now you can see only one because one is removed everything. Okay. Now next, if you want to remove the images mean image. Don't be confused with the image and the containers. Container is basically once your image is ready, right? Once your Dockerize image is ready, the image can be deployed or image can be run in your containers. So container is nothing but it is just lightweight isolated environment that has all your application related core components such as libraries, system configurations, and binaries, everything, right? So that means image is just a base image. That means you would have a containerized image. In my case, if you type here now Docker image, you can see um, you can see this many images. Right now the image is we were using the Nginx, but sorry Ubuntu we use, right? Here is there. But if you remember, the container we have removed it, but image we have not removed it, right? This is the image actually because we are taking the base image as a Ubuntu. The container we have removed because container is a different concept, but they work together, right? First, you will have a image. That image can be deployed in your particular environment that is a container. Okay. So in my case, we have now. How can I remove this one? So to remove this particular Ubuntu, let's say I'll remove this hello world. Okay, let me just select this one. In order to remove Docker RMI. Why RMI? RM means remove. I mean image. So I mean image. Okay, I will type here. Then I will have to type here hello world sudo. Okay, then I can type hello. Okay, now I can type hello world. Now we can see what is a conflict. Force using it because this particular is using any somewhere, right? So okay, let me remove which is not running right now. As I told you, this image also if it is running in some other containers, let's say this image that is your Ubuntu image is running as a container somewhere, then this cannot be removed. Or if you want, you can do a using a forceful using mass force. In my case, we are not using Ubuntu right now. So I can remove. I should be able to remove that one. Let me show. I will type Ubuntu. Ubuntu. Now this should be able to remove because this particular is not running anywhere. Now you can see the image got removed now. If you see deleted, untag, and they will first untag the latest and then they will do whatever is in the part, they will delete it. Okay. Now if you type again once again Docker image, Now you can see I don't have the Ubuntu. I hope this is clear, right? Now let's go to the next one. We are done with this one. Exec also done. Logs. If you want to see the logs, we can also use the logs commands. Then container name. So let's say we have a running container right now. That is the Nginx. We'll try to see the logs. So I will have this container name. First, I will have to type docker ps. I have this container, right? I will just copy this now. I have this one. I have copied. Now I can type sudo docker log logs. Okay. Then I can give a container name. Well, I don't know why it's copying like that. Nginx -01. Okay. That means I can see the logs. So let us see what logs actually we can see here. What we need to notice here, as I type here logs, like using the docker logs and particular container name, the logs basically we are checking for particular container that is your nginx 01. Now that means whatever happening in the background, right? So these all the logs, where the issue is, what is the things like that, what is going on in the background, every single things we can be or we can see here. Say for example, you can see here entry point, we have this in docker encryptor, this is not empty, the some directory, and will assume. So you can basically go through every single things if there is any issue also. Okay, so work progress they will see. But if you want to see actually troubleshooting point of view, what we need to understand, this logs basically on the high level you can check if there is an issue or anything like that. But then actual troubleshoot we will not do here. Actual troubleshoot what we will do, we will use, let me go back as in documentations. You can see inspect. Inspect what it does basically, docker inspect and container name, uh, display container informations about a container. So basically, let's say I want to see the container information. Let's say what is the network, what kind of they are using it, how the net containers are connected each other. This all information can be seen as an inspect. So what I can do, I can simply change this one because this should be done in your running container. Even stop also we can do it. So what we'll do, I will run docker sudo docker inspect, right? Inspect, then nginx. As I told you, you can call with ID also, container ID also, that also works fine. Okay, 01. Now let us see. Now first thing what we need to understand here, this looks very big for us to understand. Let's not go the details, but for now let's understand the high level. So as I type docker inspect and particular content basic, I want to set the configurations or details about particular containers, right? This is a container name. Now, first thing, this is the ID basically of container. So if you remember, whenever we use the Docker pull and particular, I mean, what after building, once you build the Docker build commands or Docker run commands, we get the ID, right? Once image is created, basically this thing. This is the ID basically of a container. And when it is created, you can see here also, right? This is the time we created and what is a path. This is all by default. You should not be thinking much. This is arguments. In arguments, we as mentioned, this is a nginx. This is a daemons. This is off. And now state. State means now you can see the this particular container, right? This particular container. What is the state right now? It is right now running. Whether it is running, yes, it is true. It is anything pause? No, it is false. And restart, false. Restart means there is a policy. We will discuss that later. Okay, but for now understand this, anything restart policy is there? No, it's not restarted. uh, this is a kill and a dead false. This is a basically ID. Basically it has for each one process ID would be defined here. Execute 0. 0 mean there is nothing, no issue. Okay, error, nothing. You can start, you can see. So basically every single details about the containers you can see here. Then second thing, as I mentioned, this is a image and you can see the full part. You can see everything here, even the name, whatever name of the container name you can see here, and the register count also you can see, and what is the driver we are using here. This one platform we are using Linux, because Ubuntu mean that is a this thing, right? Nginx, it is running in the Ubuntu or Linux. I mean, mount level nothing, process level nothing. So there are so many things. Host config, blind, okay, nothing to discuss here. But if you think one more thing, as I mentioned, this is very important, right? I have told clearly, right? Whenever you create a Docker, this thing, by default, Docker basically will be creating a this thing network, right, for you. So by default, Docker breeze or mode will be as a breeze network. So that is your default network. Breeze mean that port within this thing, they'll have a access, or they'll have a communication between them. Now we can see the port binding. We didn't define a port binding. We defined a port 80 port, and you can see this is a host port. What did I say? Host port is something that is locally that you define. This is a host port, and this is a port for your particular containers, basically, right? Next, register policy. As I told you, we will discuss later. Nothing, we didn't define a register policy, so I don't have to discuss much here. But yeah, let me check down if anything. Yeah, if you want, you can check all these details also, link. You can go through when you create isolations and the memory and other things, quota, everything, you can check it here. So if you come down later, as I mentioned, this is the thing we need to understand part everything. Okay. And the last, we also need to check network here. As I told you, this is a network. This is very important. You can see the what is the sandbox ID, everything you can see here. Key, port, everything you can see. So if you want to see the which network this particular container is used, you simply come and use this one. Under network settings. You can see this is using a bridge network type as a bridge and particular ID. As I mentioned, this network can be attached or de-attached, depends on the your this thing. You can attach or de-attach to particular containers as well. Okay. So yeah, this is the high level, and you can see the gateway IP as well. Okay, this is all for now. You can understand, and let me this thing. Now next, logs we have understood history. History basically show the history of an image. Whenever you basically build the image, let's say we have an Ubuntu image, right? If you type the maybe sudo docker images, right? If I see the images, I have two images. Let me check these images nginx now. So nginx, if I type docker sudo, I need to type on docker. What is that? What we are going to do? Histories. We are going to check the history, right? History basically while building the images or this thing, what happens in the background, right? History. His history or history. History. Okay. History. Okay. Then I can mention the image name in my case nginx. Nginx I have it. Now I can see here. So now what we need to understand here, whenever you basically get the image this thing, you can see first thing image and created by, and you can see here first thing this is the image this thing, what you call nginx. This is dimension of and stop signal. So basically whatever happening in the background, everything workers copying this thing and then running the script and trying packaging and also labeling everything. So basically you'll get every single things. So if you have any issue while building the image, while building docker image, you can check this history also, like which layer having issue. Now if you see here there is a missing also is there, right? So there should be some component which is required. So that is where you can also identify it. Okay. So yeah, next is I think prawns. As I mentioned, prawn is something like remove all stop containers, danglings, image, unused networks, everything. That means if you have anything unused one, you can use this thing. So this one carefully you have to do it, because if you do this thing, even whatever you stop containers or maybe anything, it will get remove everything whichever not being used, it will be removed. So carefully you run these commands. Okay, that's all I think for today. So yeah, Thank you, team. Maybe we'll wind up the session here. So we will see you maybe tomorrow again on with different another topic. Yeah. So have a nice weekend. Take it.